All right, so what I would like you to do is see if you can figure out what this expression would be. And you can use any way of thinking that you want. Try to figure out what 5x cubed squared would be. List our answers here, and then we'll see what all our different choices are, and we'll see what we come up with. Do reason after. Okay, so I see William has an answer. He has 10x to the 6. Does anyone have a different answer than that? I want all the different answers that there are. I'm just going to list them here. Yep.
5x.
5x to the 6. And then any other answers? Yep. 25x to the 6. Any other answers? Everyone had one of those three? Okay. All right, so do you see that this outer square here that I'm going to do in red means that I want to multiply whatever's in the brackets by itself? Can everyone buy that that's what that means? That exploded 2 means? That I want to multiply whatever's in this bracket, because this is the base of the exponent 2 by itself. Does that make sense to everybody? Okay. Now when you multiply those two things together, what are you going to get? You learned that part yesterday, yeah? 25x. 25. 5 times 5 is 25x to the power of 6. So this one was correct. Okay? All right, so we're going to try another one just similar. So get ready to try it. And then I'll put our answers over here. Okay, I'm picking on William again because I can see his. He's got 64x to the 8. Anyone got something different than that? Yep.
64 to the 6.
Okay. Anyone got anything different than that? So it's between these two? Okay. So if I look at this 3 as meaning that I have to multiply this by itself 3 times, that is something we learned how to do yesterday, right? So if I'm multiplying 3 algebraic terms together, I multiply the coefficients together. So 4 times 4 times 4, and that's 64. So far they're both right, right? And then if I multiply x squared by x squared by x squared, what do I get? Yeah.
to the power of 6.
X to the power of 6. So you keep the base x and you add the exponents. 2 plus 2 is 4, plus 2 more is 6. So this one is correct. Okay? All right, so reset. We're going to try another one. I'm going to start showing 2 ways to get the answer here because I see people doing it 2 ways. So I see a 32x to the 20th. I see a 16x to the 20th. Another 16x to the 20th. Another 16. Another 16. All right, so that seems to be the consensus, is the 16 is the one I see the most often. All right, so if I multiply this out 4 times, which that 4 means, I multiply the coefficients, so 2 times 2 times 2 times 2 is 16, okay? And then x to the 5th times x to the 5th, times x to the 5th, times x to the 5th. I keep the base and add the exponents. So 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. Now I also saw people doing this. They went 2 to the 4th, x to the 20th equals 16x to the 20th. Can somebody that did that explain their thinking? Yes.
Well, I just thought it was like another way of like simplifying it, sort of.
Yep. So how did you get the 4 here is my question.
So I know that right now the 2, it's to the power of 1,
Awesome.
but you need to multiply it by the exponent outside the bracket.
Yes.
So it would be 2 to the power.
Yes. Does everyone see that? So this 4 applies to the 2, which has a power of 1 right now. 1 times 4 is 4. And it also applies to the 5. 4 times 5 is 20. Okay? So either way, you get the answer. Okay? Everybody good there? All right, so let's try another one. Yes. Okay, I see a 216x to the 6. 216x to the 8. Okay. Another 316 next to the 6. And I'm not sure. Another 316 next to the 6. Okay, looks like 216 next to the 6 is the consensus. So let's see. So our new way of thinking about it would have been to do 6 to the power of 3, because 1 times 3 is 3. X to the power of 6, because 2 times 3 is 6. And then put in my calculator, 6 to the power of 3, or 6 times 6 times 6 is 216, x to the 6. And then our other way of thinking about it is to multiply this by itself 3 times. And there we would multiply 6 times 6 times 6. X squared times x squared times x squared means keep the base and add the exponents. 2, 4, 6. Okay, so we've demonstrated that that was the answer in 2 ways. Okay. Negative 3x squared to the 5th. Okay, so I see consensus of negative 243 x to the 10th. Okay, I saw a couple of x to the 5th, but that seemed to be the one that was most often I saw. Okay, so here's how you can write it. Okay, so we'll look at 3 ways. The first way is to go straight to the answer. So to go straight to the answer, you have to see that I'm typing into my calculator negative 3 to the 5th to get the coefficient. Okay? And I saw there was about 6 of you that went straight to the answer. So you knew then that you wanted to do negative 3 to the 5th, and you got negative 243, and then x to the 2 times 5 is 10. Okay? That's one way to do it. The second way to do it is to put that middle step in there, but be careful when the middle step has a negative. So I saw people writing this. Who can tell me what's the little communication thing wrong with writing that out? Carter. Negative 3 isn't in the bracket. So that's what you want to actually put to the exponent of 5, so you need brackets around that to show it, okay? If you're going to put your middle step in, which I advise, x to the 10th. And then you type that in your calculator and you get negative 243 x to the 10th. Okay? And the third way to do it is to write it out 5 times. One, two, three, four, 5. And then multiply all your coefficients together, so get your calculator out and do negative 3 times negative 3 times negative 3 times negative 3 times negative 3. And then x to the 2, 4, 6, 8, 10. Okay, so there's 3 acceptable answers for me. Okay, all of them would be a thumbs up. Okay. All right, here's one. 2x squared y cubed to the 4th. 2x squared y cubed to the 4th.
Okay. Consensus answer here we've got is 16, x to the 8, y to the 12. Very good. Okay, and I saw 4 different ways of getting to the answer, which was awesome. So you have your understanding built in your head of how this works. Okay? So some people just went straight to the answer. So they typed 2 to the 4th in their calculator and got 16. So really mentally they're thinking 1 times 4, so it's 2 to the 4th, x to the 8, y to the 12, okay? And then I had people with the middle step here where they did this. So they didn't need brackets this time because the base was positive. So they put a middle step in. And then I had people write it out 4 times. But no matter what way they did it, they all got the same answer, which is awesome. So good job. All right, put the stakes up a bit more here. Let's see if we can do this one. All right, so I got a few more different answers here. I got 4x over 25y. I've got 4x squared over 25y squared. I've got 4x squared over 10x squared. Are the answers I've seen as I've walked around. Okay, so let's see which one we can reason through is right. So if we use our rule from yesterday where we apply the numerator, that exponent to the numerator, and that exponent to the denominator. Does that make sense to everybody? That we would do that? Apply the exponent to the numerator and to the denominator. Okay? So from there, some people went straight to 2 to the power of 2 is 4, x to the power of 2 is like there's a 1 times 2 there. And then 5 squared is 25. Y to the power of 2. And some people from this step, they went to 2x times 2x over 5y times 5y. And they got 4x squared over 25y squared. Okay? And then some people just went straight to the answer. Good. Okay, let's try another one. Okay.
Same? Okay, so very good, that's awesome. So I had people doing they went straight to this stuff where they applied the cube to the top by writing it out 3 times, and to the bottom by multiplying it together 3 times to get the answer. Had quite a few people do that, and end up getting negative 27 x to the 6 over 64y cubed. Then I had people going straight to the answer. So to do that, they were thinking negative 3 to the power of 3, x squared to the power of 3, I keep the base and multiply the exponent. 4 to the power of 3 is 64. Y to the power of 3 is y to the third. Okay, so that 3 has 4 jobs, 1, 2 on top, and 2 jobs on the bottom. Okay, and then I had people writing in the middle step, which should have looked like this with the brackets: negative 3 cubed, x to the 6, over 4 cubed, y cubed, and then figure those numbers out. Okay, I feel like you guys are ready. So that's our extra step today, is having the number to the power as well. Okay, keep your whiteboard out if it helps you to do thinking on the side while we're doing the lesson. And the lesson is short, see, 1 page back in front. Okay, and you'll have something to look from. Yep. Because they don't go into each other. They don't have you can't reduce that. Like it's not they don't have 10 on top and 5 on bottom. I know what you mean. And plus we have x on top and y on bottom. They don't combine, but that's a good question.
And I'm not going to get an error.
Okay, we're doing really well on exponents, guys. Today's our last video on exponents, and tomorrow we start, you're welcome. Simplifying algebraic expressions, and on Friday we start solving equations. It's been a lot of weeks. Okay, so lesson number 5, exponents, the power rule with algebraic terms. So we're learning that a coefficient has an exponent of 1, okay, which we talked about during the whiteboard activity. We're learning to apply the power rule to algebraic terms, and we're learning to simplify algebraic expressions involving exponents. So this rule looks really crazy here with the m exponent, the n exponent, and the p exponent. They just represent any number. Okay, so if you have this product to another exponent, then you keep the base x and multiply the 2 exponents here. Maybe I should do that, and then you also multiply those 2 exponents, okay, on the y.
And there's a description in words. When raising a product of powers to an exponent, keep each base the same and multiply the exponents. And here's my example. Okay? So if you have x to the fourth, y to the cubed, all to the fifth, it's x to the 20, and the 20 comes from 4 times 5, y to the 15th, and the 15 comes from 3 times 5. Okay? And same thing with a quotient. All right, when dividing powers with the same base, keep the base and subtract the exponents. That shouldn't be what I was saying there, because that's not what I'm saying there. Sorry about that, just cross that off. Must have been late at night when I was filling out that column. I didn't change it. So this is similar to the one where we have a fraction raised to an exponent. You raise the numerator to that exponent, and you raise the denominator to that exponent. Okay, same idea. And here's an example. So we have a to the fourth over b to the seventh all cubed. You raise the a to the fourth to the power of 3 by multiplying, and b to the seventh to the power of 3 by multiplying. And then this is our new one that we were spending the most time on the whiteboards today. So C is a coefficient. And remember, the coefficient is a number. When raising an algebraic term to an exponent, apply the exponent to the coefficient, the number up front, and to the variable. Okay, and then I did an example off to the side. We have 2x to the fifth to the third. It would be 2 cubed, which is 8, and x to the 5 times 3. Okay? Which is kind of our rule we figured out on the whiteboards. All right, so we're going to practice. So if you need the whiteboard to do some thinking, you guys should be able to do A, B, and C. So I'm going to give you time to try those. A, B, C, and E, and try D. You need the whiteboard to do your thinking? Go ahead. Yes, exponents. Our second day on exponents. And we did some whiteboard work, so we're kind of on the same page here. Cool. Yes. So, as I was walking around, I noticed tons of people had the correct answer here. So I saw lots of 81x to the 8. A lot of people use their whiteboard to write it out 4 times to get the answer, okay? And then a lot of people have this middle step in, 3 to the 4th, x to the 8, okay? And then the question to me was asked, if I'm doing this work on my whiteboard, can I just write the answer down? And the answer is yes, okay? Okay? If there's no middle step to show, like this is your middle step if your thinking is 3 to the 4th, x to the 8. This is your middle step if your thinking is I'm multiplying this by itself 4 times, okay? But if she didn't have room to do it here, but she did all the thinking, she got the answer, okay? Great. This one, same thing. I saw a lot of people just writing 64y cubed down, so they were able to think 4 cubed, or y cubed, and then some people had the middle step in there as well. Okay, this one, 2 to the 4th is 16, x to the 20th, y to the 12th, okay? All right, this one, has anybody brave enough to try it? I think they have it, some people did, yep.
So the first step is 3x to the power of 2
Yep.
times 3 to the power of 2 x to the power of 2.
Lovely. That's awesome. Way to go. Okay. Do you have next step for me?
3x to the power of 2 times
Yep.
9x to the power of 2.
Perfect. And then your last step.
27x to the power of 4.
Awesome. How many people got that? 27x to the power 4. Okay, so this was actually an EQAO question. They want to see if you know the difference between 3x squared and then 3x all squared. And Austin definitely knew the difference there. He showed that he knew the difference. Yep. You may go to the bottom. How about 5a to the 6 squared? Anybody get as far as that one? Yep. Vanessa?
5 squared,
Yep.
8 power 12,
Yep.
and then 25, then 8 power 12.
Awesome. Okay. All right, so let's try the whole next row. Okay? You need your whiteboard to write down your thinking, use it. And I'll pause it so Dusty doesn't have to watch how small it is. Start taking up F. Does someone want to give me their solution? Whether it took you 1 step, 2 steps, I want to know what your thinking was. Yep. So my first step was negative 2 to the power of 3 with base.
Do you have brackets around the negative 2?
No. Should you have?
Yeah.
Yes. Awesome. Good. Then I bet you a lot of people did that. If that was your first step, you needed brackets around the negative 2. And then 8 to the 6. Perfect. And then what was your second step?
I got negative 8 with 80 to the power of 6.
Perfect. How many people got negative 8 to the power of 6? Look at that. That's awesome. Okay. Who thinks they got G? Vanessa.
Negative 5 to the power of 2,
Yep.
and y to the power of 3,
Good.
and then negative 25 to the power of
Negative 25.
5, and then y to the power of 2.
Okay, how many people got negative 25y squared? How many people got positive 25y squared? Which one is it? Positive, good. Negative 5 times negative 5 is positive 25y squared. Good, good. Okay, who thinks they can tell me h? Yeah, William?
Like just the answer on
Nope, how you got it?
2 to the power of 3,
Yeah.
and then x squared to the power of 3,
Which is x to the power of,
6,
yep,
and 5 to the power of 3,
yep,
and y to the power of 3,
perfect.
and then that equals 8,
Yep,
x to the power of 6,
yep,
over 125,
yep.
y to the power of 3.
Perfect. Okay, who wants to tackle I? Yep,
4 to the power of 2,
yep.
over a to the power of 6.
A to the power of 6, yep.
Or sorry, I didn't say over.
Yep.
Over 3 to the power of 2, b to the power of 10.
Awesome. And then your final answer?
16, a to the power of 6,
Yep.
over 9, b to the power of 10.
Awesome. How many people got that? Good, good. And if you didn't, I hope you see where your mistake was. Okay, here's the kicker for this page. Does anyone want to try this one? Yes.
So 6 to the power of 3,
Yep.
x to the power of 6, y to the power of 3, over negative 36, x to the power of 2, y to the power of 3.
Perfect.
And I got 216 x to the power of 6, y to the power of 3, over 36, x to the power of 2, y to the power of 2. And then I have 6 x to the power of 4.
Awesome. How many people got 6x to the 4th y? 1, 2, 3, 4. Okay. Any questions on any of his steps there? Yep. Oh, you're right. How many people got negative 6x to the 4th y? Look at way more people. That is awesome. That is a hard question, right, Mr. Diego? Like, that's hard. Okay. Way to go. And you beat
You beat the teacher. Way to go. What you always want to do is beat the teacher. Okay, so now I've mixed up all the exponent rules that we've done, okay? Yep. Yes, I can for sure. If you're starting the next example, I've mixed up the rules. So some of it's just straightforward what we did yesterday, and some of it's got that coefficient inside to power. So be careful and think through each question. So you've got so many exponent rules in your brains right now. So you want to ask yourself, what am I doing here? What am I doing here? So you're going to try, let's try A to I. What time are we at? 9:24? And then I'm just going to leave for 10 minutes thinking time. Okay, Mr. Jigo and Evan are going to circulate and help you if you're stuck. A to I, and then I'm going to come back and take them up. Okay? A to I, go. Am I paused? I should be paused here. Here we go. All right, so who thinks they've got question A here? Vanessa? Nobody? 8? Yeah? 8x to the power 4. Check your work. 8x to the power 4. Yes? Yes. Okay, who thinks they've got B? Carter. Good. Why is this one a bit of a thinker? What made you think if anyone had to think on this one? Yep. Because weren't the same, right? So this one had an X in it and this one didn't. Did that make anyone think for a second? Okay, good, good. I'm glad you came up with it. Okay, this one's similar. What did you get for C? Yep.
5 and power 2.
Okay.
Power 5.
10 to the power 2, p to the power 5. Okay, I like that. It's not quite simplified. That's correct, but that's really a -1 there. So you can multiply the 5 by the -1 and get -5m squared p to the 5th. Yeah?
Okay, I wrote it in -5p5m squared.
Yep, that's fine as well. Yep, the order of your variables doesn't matter. A textbook convention would be alphabetical order, but it doesn't matter as long as you got the right exponent on the right one. Okay? Okay, so who thinks they've got D? Yep.
7 to the power 3 and x to the power 6.
Yep.
And then 343 with x to the power 6.
Perfect. Okay, and who thinks they've got E? William.
2 to the power 2. X to the power 2.
Yep.
4. X to the power 2.
Perfect. Who thinks they've got F? Yep. Logan? Sorry, Logan.
729 x to the power 30.
Okay. How'd you get 7 to 29?
-3 to the power 5.
Try that on your calculator. What did you get for -3 to the power of 5?
I got -243.
-243. Good. I think you might have actually accidentally done it to the power of 6 instead of the power of 5. Okay? Did you write in the middle step or did you go straight to the answer? Amelia?
I did, yeah, -3 to the power of 5x. And then I got 30.
Yes. Good. Good. Okay, so that would be the middle step. Make sure you have the brackets if you're doing the middle step. All right, who thinks they've got G? Yep.
-4 to the power 3.
Awesome. How about H? Yep.
-4 power 6.
Yep. Awesome. You guys we're doing so many different rules here and you're keeping them all straight. That's really, really good. All right, who thinks they've got I? Vanessa?
6a power 3.
Yep. Good. And this was another one of those where we didn't have the same A and B in each bracket, but we figured it out. Good. So we had an A squared times an A and a B squared times a B. Perfect. Perfect. Okay. Do you want some time to try J, K, L, and M?
Did you get to them, Mr. Diego? Got to them? Okay, so who thinks they've got J? Yep.
Negative 20 x 15 each. Negative 20 x to the power of 15 h to the power of 3 times negative 3 h to the power of 2, which is 60x to the power of 15 h to the power of 3.
Okay.
And you should all brackets.
Are you good there? Okay. Could I have gotten straight from here to here? Yeah, I could have done that as well. So I could have done 4 times negative 5 times negative 3 to get the 60. And then f to the 9th times f to the 6th. Oh, there's not an f there. Oops. And then h cubed times h squared. Yes, I could have. Okay, so either I could show a middle step or I could go straight to the answer. Who thinks they've got K? Yep.
32
Yes.
e to the power of 3.
Awesome. Good. And how do you get the 32?
T to the power of 5.
2 to the power of 5. Okay. Awesome. Good. Who thinks they've got L? Yep.
7 e to the power of 3.
Yes. So that was just 7 divided by 1, which is 7. Perfect. And what about M? Yep. So 7 to the power of 3 with b to the power of 15 over b to the power of 6. Nice. Which is 7 to the power of 3, and then you get b to the power of 9. Yes. Which makes 343 and b to the power of 9. Very good. How many people got 343 b to the power of 9? Nice. Very good. Excellent. So here, William, here's an example of where we did divide, because we had the same base in the top and the bottom. Okay? Yep.
So on the second line there, it says, no, the first line says b to the power of 6.
Yeah.
Yes.
Okay.
Yes. Good. Okay, and then this one was in, I think it was in the knowledge book yesterday. What value of m makes the equation true? So we have 6a to some number divided by 2a cubed, and it's ending up being 3a to the 5th. And your question is, what number goes in for m? Yep, 8. So 6 divided by 2 gives you the 3. A to the 8 divided by a cubed gives you a to the 5th. Everyone see that? Okay. And you could, if you want, just try them all out. You could try a squared out here. 2 minus 3 is not 5. Try 8 out. 8 minus 3 is 5. Okay. So do you see that? Are you doing it? All right. And which of the following is not equal to p to the 6th? Yep. C. Because p cubed times p squared would be what, Carter? P to the 5. So all these other ones are equal to p to the 6. Okay? Great. I'll get Evan to hand out the practice. I'll post the regions. So this is everything mixed together. And I'll start recording this.